So we have learned there are two ways of representing binary trees, using linked lists and using arrays. In this lecture, let's see which common operations can be performed on binary tree, and then we are going to create binary tree using linked list. So in case of binary tree, we can perform following operations on binary tree. We can create binary tree, we can insert a node to the binary tree, and we can delete a node from binary tree. Then we are going to perform search for value inside binary tree, then traversal of all nodes in the binary tree, and deletion of tree from the memory. So we are going to perform these operations over here using linked list and array in this course. So the first operation that we are going to perform is creation of binary tree using linked list. So here, as I mentioned in this course, I'm going to implement all operations using linked list and array in practice. So let's see how can we create a binary tree in terms of linked list. So here, all we have to do, we have to create an object of binary class over here. So with this, we can successfully create a binary tree using linked list in this case. Now let's switch to Java and implement creation of binary tree in case of linked list in practice. Now here, the first thing that I'm going to do, I'm going to create binary node. So as we mentioned, in case of linked list, when we are creating a binary node, it will be consist of three components. So the first component will be the value, the second component will be left child reference, and the third component will be right child reference. So based on this, we are going to create binary node over here. So I'm going to create a new file and I will name it binary node.java. And inside this file, we are going to create our binary node class. So I'm going to name our class like this, public class binary node. So as I mentioned, in this class we are going to have three components. So the first component will be the value of the node. So in this case, for simplicity, I'm going to create the type of string because I'm going to create the tree that we have explained in our slides, which are showing the drinks in cafes menu. So that's why I'm putting string over here, but we can implement the class in the way that the type of value can be selected while we are creating a binary node over here. But in this case, for simplicity, I'm putting inside binary node a string. Now the next component that we will have in our binary node will be the left and right children. So in this case, I'm going to create it like this. Public, so it's going to be the type of binary node, left, and we are going to create another one which will be the same as left child, binary node, right. So in these components, we will have left and right child of this binary node over here. Now the next component that I'm going to create over here is, which will be used in the future when we are implementing other methods, will be the height of this node over here. So I'm just creating it from now because we are going to use it when we are implementing our other methods. Now here is going to be the type of integer. Now with this we have completed binary node, so we are going to continue to create binary tree class in terms of linked list. So I'm going to create a new file over here and name it binary tree linked list ll.java. So inside this file we are going to create our binary tree in terms of linked list. So in this case I'm going to name it public class binary tree ll. So inside this class, the first thing that we are going to do, we are going to declare our root node. So the root node will be the type of binary node. So I'm just going to copy it from here and paste it over here, root. And then inside constructor, we are going to set root node to null, because when we are creating a tree, in this case, we don't have any root node. So that's why I'm going to set it to null. So inside constructor, I'm going to set this one, this root, to null. Now with this, we have successfully created our binary tree using linked list in this case. Basically what we are doing over here is we are just creating root node and setting this root node to null in this case. Now let's see how this is working in practice. Basically, as we mentioned, when we are creating a binary tree in terms of linked list, we are just creating an instance of this class over here. So inside main class, I'm just going to create an instance of this class. So it's going to be binary tree equals new binary tree, something like this. Now in this case, if I run our code, it's not going to happen anything. In this case, it's to just create binary tree in the memory. So as you can see, our code does not return anything. So we have successfully created our binary tree in the memory without having any node inside this binary tree. Now let's see what's the time and space complexity for creation of binary tree in terms of linked list. So in this case, as you can see, we are just setting the root node to null inside this constructor. So this means that the time complexity for binary tree in terms of linked list will take O1 time complexity. Now the space complexity is also O1 because in this case, we are not performing any space consuming operation. We are just creating an empty root node in the memory. So it's not taking any memory. So that's why it will take O1 space complexity. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented binary node in which we have 3 components, and we have implemented binary tree in which we have only empty root node. So hopefully everything is clear about creation of binary tree in terms of linked list. Now in the next lecture, we are going to implement traversal of binary tree. Now you might be interested why we are learning traversal before inserting any element to this binary tree over here. So the reason is when we are inserting a node to this binary tree, we are going to use traversal methods heavily. So that's why it's better to learn traversal first, then we are going to continue to the insertion of a node to the binary tree. So see you in the next lecture.